And now, please welcome to the stage Senior Information Security Engineer at Synopsys, Chanda Pulliam.
Guys, so much. Can you hear me okay? Wonderful, wonderful. Hi, my name is Chanda. I wanted to give you a little bit of about me before we really began. Unfortunately, I was really struggling with how to put this into words. So my 8-year-old son said, use ChatGPT, have it write the about me section for you. So I did. It was great, guys, okay? Are you ready? Welcome to CribbleCon. My name is Chanda Pulliam, and my introduction into technology is a rather unique one. You see, I was working as a marine biologist, volcanologist, off the coast of Finland, looking at data on the seismic activity of whales, when it occurred to me, the thing I like most about my job is logs. No, I'm kidding. What? Logs, woo! But no, it's, what is a volcanologist? It sounds like Star Wars. But no, I've been in this industry for about 25 years now. I started out in help desk, very young, kind of bounced back and forth between help desk and management and then engineering. About 4 years ago, I was introduced to Elasticsearch and had been working with that until we began working with Cribl back in October 2023. I have 2 kids, not just the one that likes ChatGPT. And a fun fact about me is I'm terrified of horses, and I think you guys should be too. So they're big and they have teeth. Very scary. So I wanted to bring this slide out because I think we can all relate to how annoying it can be to try to parse and manage logs when it takes 48 different events just to do one install in Linux. So, to me, that's pretty relevant. So I want to start this talk. The first part is going to be about Elasticsearch and how my company was able to use a mapper size plugin to accurately determine what we were saving in storage and usage by moving over to Cribl. So to set the stage, prior to Cribl, we were using Docker containers, Logstash, FileBeat, AuditBeat, WinLogBeat, Fleet, and numerous other tools. And of course, everyone's favorite, that custom Python script that you have to write because so-and-so's API is wonky. We were getting a lot of duplicate data. We were getting events we don't care about. And we were getting fields, source IP one place, client IP a different place. And there was just no consistency. And then, of course, we were getting fields in important events that we didn't actually need at all. So we wanted to use Cribl to improve our event routing flexibility. We didn't want everything going to the SIM. We wanted some things going to a data lake and other things going to a SIM. We wanted to simplify the onboarding process. No more 500 Docker containers on 12 servers around the world. We wanted a single UI where we can handle everything. And we wanted to decrease the strain of compute on our SIM so the SIM can do what's important, which is actually identify and detect, bad guys. And we wanted to be able to improve our data retention and retrieval. We actually used Cribl Search for that, but that's what we were wanting to do. So before we could really dive into that, we needed to know where we were. We needed to understand what our largest and smallest log sources were. We needed to know the percentage of ingest these log sources were from a holistic standpoint. And we wanted to be able to identify anomalous changes in the size of our log sources. So we used what's called a mapper size plugin in Elasticsearch to achieve this. We were hoping that doing this would allow us to identify where we can cut out the noise and then ultimately decrease the amount of storage and ingest we were sending to Elastic. On top of that, the executives were always asking for numbers. They love numbers. And using this was allowing us to show them in actual dollar amounts what we were saving by moving to Cribl. So a few considerations when you're sizing an Elasticsearch event is Elasticsearch does have compression. I have seen it anywhere between 30% compression to like 90% compression. But what I do know is that it's pretty static. So once you know the size of an index and you know the size of the events hitting the index, you're going to know the compression ratio permanently. This plugin is not enabled by default. It's not hard to enable, but it's not enabled by default. And I personally recommend, once you do enable it, that you give the logs some time to marinate, right? Some time so that you can have a foundation of how much data this is getting on this day at this time, so that you can compare it to what you're getting in Cribl. So, and last consideration, if you're running a self-managed Elasticsearch cluster rather than Elasticsearch Cloud or Elasticsearch Cloud Kubernetes, then it's going to require a rolling restart that you'll have to do manually. So this screen, I just wanted to give you guys links on how to do this process on your own, but I actually have a demo that I wanted to go ahead and bring up now so I can walk you through the process of installing this plugin and then showing you how we were able to use it. There we go. All right, so this demo takes place in the cloud. The install part of this demo is a little different on-prem, but once it's installed, everything I'm going to show you is going to be about the same as what it is in the cloud and on-prem. So we're going to start this out, and it might take a moment to catch up here, by going to the actual deployment. And again, this is Elastic Cloud. So we're going to edit the deployment. And we're going to go to Manage User Settings and Extensions. From here, we're going to go to the Extensions tab. At the very bottom, you're going to see the Mapper Size plugin. We're going to go ahead and check that box, go back, and then we're going to save the changes. Go ahead. And so right now, Elasticsearch is actually deploying the plugin to the nodes. Once it's done, this plugin is going to be available for you to use. That doesn't mean the plugin's already going to be turned on and you're going to start getting data immediately, but you're going to be able to turn it on. So right now, it's there, but it's not available. So this is what it looks like once the plugin has been completely installed. There it is right there. And we can go back into Kibana so that I can show you how to add this plugin to the actual indices that you're looking for. So moving from this point forward, the steps are going to be the same whether you're on Elastic Cloud or Elastic on-prem. It's all going to work the exact same way. So for this demo, I have actually stood up 2 different indices. The first index that I stood up, I've already applied this plugin to that index so that we have data rolling in that I can show you. The second index, I'm going to show you now so that you understand how easy it is to actually install this. So we're going to go into Index Management and then Index Templates. From here, you're going to locate the index pattern that you want to modify. And we're just going to bring that up and edit it. We're going to go to Mappings, Advanced Options. And if you scroll down to the bottom, you're going to see the Size Mapper plugin can now be enabled. This was not here prior to us doing this install. We're going to check it. We're going to apply these changes. And then we're going to close out of it. So now this index template has the plugin installed. We still, if we want the changes to be immediate, we're going to have to roll this index over so that it applies the updated template, which is what we're going to do right now. So in this demo, I wanted to show you what this looks like when you make this change immediately. Unfortunately, the log source that I was using wasn't noisy enough that I was getting results immediately. So we're just going to go into Discover, and I can show it to you from there. So we're going to bring up a document here. And if you go over to JSON, you're going to see where we have the plugin right now. This is the size metadata field. It contains the uncompressed size of the event the moment it hits the SIM before it's indexed. So, and it is a metadata field. The one thing to keep in mind, metadata fields are not super easily parsed or aggregated. So we have to go in and create what's called a runtime field that allows us to create dashboards and visualizations and do aggregation that wouldn't otherwise be an option. So we're going to go to Dev Tools, and I've got a little script here that will do this aggregation for us. So this script actually creates an event.size field that contains the value of the metadata field that we just added. So we're going to apply that. And then we're going to go back into Discover, and you're going to see how it looks in here. So we're going to bring it up, and it's going to show you that you now have an event.size field. This is a runtime field. It doesn't take up space. It's just a query that runs whenever you are looking at the data. One of the ways I like to do aggregation here is to go use ESQL because I just think it's awesome. So I actually have data moving in here from the original log source as well as from Cribl. And the point of that is it's allowing me to do a side-by-side comparison between what we are doing in Cribl and what we are doing prior to Cribl. What this is going to allow you to do, and I recommend this in pre-production, because you can do a bucket comparison hour by hour, minute by minute if you want, of how the data going through Cribl looks versus how the data looks outside of Cribl. So we're using the log.source field, which is one I created. And you're going to see here, the green one is the original log source, not going through Cribl. The blue one is going through Cribl. Now, there are additional parsing opportunities here. We just didn't apply them in this demo. But this will allow you to see the changes over time as you're changing the parsing in Cribl. You're going to be able to see the impact it has on the logs compared to what's hitting it originally. So at Synopsys, we were able to use this information to get some pretty cool details. We were able to get not only the actual size of the events as they were hitting the SIM, we were able to identify how much storage, how much time, and how much data we were saving by making our migration to Cribl and using that to parse and chop up and clean up the logs. So the second thing I wanted to bring up here was our first migration to Cribl. It was Zscaler. This is it's a very verbose log source. And in our environment, the logs are coming from what's called an NSS server that can only send logs TCP. So we're no UDP, no HTTP, only TCP. It's very noisy, very loud, and our original configuration wasn't ideal. The logs were going to a Syslog server, FileBeat was sending them to Logstash, and then Logstash was sending them to the SIM. This was causing a problem because they were not moving fast enough. We were having some very high delays in the events hitting the SIM, and we didn't know it at the time, but we were actually losing logs because the NSS server was filling up its cache, and then it would just start dropping things. So we had a plan. We were going to enable the Cribl syslog source, redirect the logs on the NSS server from syslog to the Cribl syslog source, parse the logs with the Zscaler pack, send them on to the SIM, and then, go out and party because we're done with this. That's not what happened. When we enabled the syslog source, the first thing we discovered was a thing called TCP pinning. And what that is when you are sending the events to the Cribl worker node, the syslog source is only using a single CPU or vCPU core, and it's not spreading the workload out across multiple cores. This means it can only move as fast as a single core can move. This was causing a back pressure problem, and again, the NSS server was hitting its capacity and logs were dropping. So we tried a few other things. We tried to load balance the TCP traffic to multiple Cribl worker nodes. That didn't work. Once Zscaler found a node that would accept the connection, it clung to it, even if it hit back pressure. So then we thought, well, we'll send the logs to syslog ng, and then from there to the Cribl HTTP source. But that's when we learned that syslog ng also has the same TCP pinning problem that the syslog source had. There is an upgrade for syslog ng that allows TCP multi-thread processing. Yeah, that just broke everything. It wasn't ready for production. So ultimately, what we decided to do was send the logs to FileBeat, and then from FileBeat to the Cribl Elasticsearch source. Guys, that worked. We actually started to get the logs in. It wasn't perfect. We were still having some slowness in parsing the logs. We were having some parsing failures because of surprise events that don't match what you expect them to. And we were still having a delay of about 2 to 3 hours, which we don't want. So we decided to focus on speeding up the parsing process. We knew that FileBeat could handle the volume. We knew the Elasticsearch worker nodes could handle the volume. But there was a bottleneck at the actual parsing. So one of the primary reasons we wanted these logs to go through Cribl was because we wanted to decrease the size of them. And to do that, the lowest hanging fruit, get rid of fields that are none or null. And we wanted to do that. But using the normal parser function in Cribl, that little field filter expression at the bottom actually was surprisingly slow. So instead, what we thought we would do was before we parsed the events, we would use a mask to remove the null or none fields from the raw or the message field and then parse it. So by using the mask, we were able to decrease the speed, or decrease how slow this was from 65 milliseconds down to below 10 milliseconds for every 100 events. So the second thing we discovered was the eval expression. If you are doing a nested JSON in eval, you have to declare the root field before you can assign values to the nested fields inside of it. This was kind of slow as well. And we wanted to speed that up because we had a lot of these that we had to do this with. So instead, we created one eval that has a single root field, and then we added all of the nested fields beneath it as a single expression. So that was considerably faster. So in this process, we did a few different things to try to make this work. First and foremost, we used FileBeat to handle the initial TCP-based workload. And this was before and after moving to Cribl. Before Cribl, or during the migration, that was when we discovered that we were dropping events at the NSS server because out of nowhere, we're getting a lot more events into our SIM. That was a surprise. And then via Cribl, we were able to remove unnecessary fields. And this was a game changer. By removing unnecessary fields, we significantly decreased the total event size. So we did end up using suppression and Redis to drop duplicate events. That was powerful, but removing unnecessary fields is really where the big changes occurred for us. And then ultimately decreased the time it took to parse events for every 1,000 events from 2.3 seconds to 400 milliseconds. So how did we do? We had 48% fewer events hitting our SIM. The average event size was 57% smaller. And overall, we were using 75% less storage for our Zscaler logs. So a few recommendations. I would recommend you understand TCP pinning with the caveat that Cribl has made changes to their syslog source. And I would say we are currently sending over 3 terabytes through it right now per day with no problems. So at this point, the Cribl syslog source no longer does appear to experience TCP pinning as long as you enable the load balancing under advanced options. Another recommendation, get rid of the noise. If you don't need a field, get rid of it. If there's events you don't need, get rid of them. Focus on data that is useful to you for your use case. And the third recommendation, I know I didn't really speak about Redis here, but we've done cool things with Redis. And we've found a lot of value in it. It gets rid of duplication. It helps us do accurate aggregation across different worker nodes. And it was surprisingly easy to install and configure. So does anybody have any questions about what we did here?
Thanks. I wanted to ask about the process of, you have an engineering group that is deciding what to cut out, and you have the domain experts who want to tell you exactly what they need and what they don't. How did you set up the dialogue between the two of them as you encountered at each data set? We
actually worked with them directly. They were a pretty big part of the whole process. So there was, at times there was meetings where we were actually saying, this field right here. We have, from a detection engineering perspective, there was no value in it. Did they need it? And, so we would cut it. There were other times where we would drop a field and they were like, don't do that. So it was a little bit of a slow process, but we did work directly with them to identify specific fields and say, I don't think there's a value here. I need to understand if you do before we proceed.
Thank you.
So the moment we started using so he's asking how we discovered that some of our Zscaler logs were not making it to the SIM. So once we were able to use FileBeat to send the logs to the Elasticsearch Cribl source, the volume of logs we were getting every day jumped dramatically because we were not experiencing the delay. And that was when we reached out to Zscaler and we were advised that there is a limit to how much data they can hold before they start dropping things.
Is there any graph within Zscaler that gives you a total indication of the amount of logs coming out of it to verify up against to see if you're still potentially missing something?
Not that I've seen.
Okay.
A lot of the work I've done has actually been on the NSS servers themselves, which I think is like a version of FreeBSD or something.
Yeah.
But it does show you when you're just spiking in your RAM utilization. And if you're staying at 99% and there's a delay, there's a problem.
Okay. All right. Thank you.
My name's Chanda Pulliam. You guys can ping me in community Slack anytime you want. And I hope you guys enjoy CriblCon. Thank you.